Good day everyone. Today we are discussing about the forest graph. First, let's define what is a forest graph. A forest graph is a graph that contains no cycles and its components are all trees. It's essentially a collection of one or more trees that are not connected to one another. A forest is a type of graph that is an undirected acyclic graph, meaning it has no cycles. It is a collection of one or more disjoint trees where each connected component is a tree. This is why it is called a forest. It's a group of individual trees that are not connected to one another.
The part of forest is are three its components, which are the vertex or nodes in the edges that connect them. Trees are forest in the disjoint union of one or more trees. Each tree is a connected alcoholic component of the forest. The number of trees in forest is equal to the number of its connected component. Vertex nodes. Trees are the individual point or objective in the graph. Edges. These are the connection between vertices. The relationship in forest with trees, verticals and edges will have the priority.
Hello. Our next topic is the advantage and disadvantage of using a forest graph. The advantage of using forests in graph theory is that they provide a way to model and analyze systems that may be disconnected, and they are simpler to work with than general graphs for certain problems. These are, the first one is advantages. Modeling disconnected systems, forests are ideal for representing systems where components are isolated from each other, such as collection of different ecological habitats or a set of unrelated data sets. The second one is simplifies analysis by breaking down a complex, potentially disconnected graph into smaller, independent trees. A forest can simplify the analysis of each component as trees have a more specific and well-defined properties, for example, no cycle. The third one is analysis of connectivity. Analyzing forests can help prioritize conservation efforts by identifying the most crucial patches within each disconnected components of a landscape, as shown in studies of forest patch connectivity. The fourth one, or the last one, is flexibility. A forest can easily be constructed from each tree by removing edges, and it can be adapted to represent a system that has broken into separate parts.
Well, here are the disadvantages of using a forest graph. The main disadvantage is that cannot represent a single connected system with a cycle, and there are less sustainable for problems where connectivity is crucial. Disadvantages. Limited for connected systems. A forest is not sustainable for representing a single connected system that contains cycles, as it is defined as a collection of trees which are acyclic by definition. Maybe too restrictive if the goal is to analyze the overall connectivity of a single network. Treating is a forest might ignore critical relationships between components that are represented as parts of the same tree. In applicability to certain problems, graph algorithms that rely on a single connected component such as certain network flow algorithms are not directly applicable to a forest without modifications.
Here is an example of a forest graph. A marketing project teams include members from IT sales and customer service. Subsidiaries each would connect this individual indicating their collaboration action. It form project teams with members from different subsidiary companies. Graph connection. The each are representing collaboration or reporting relation on the project.
Example number 2. is independent social network within a platform. The nodes are the individual users. The edges are the relationship like friend, followers, or connection. And the each tree representing an independent social network, where users are connected within the network but not to user in the other network.